The following program is brought to you by Caltech.
All right, our next talk is by one of our students, Pascal Renten, who will be presenting some of his work with ISECG on NEA scenarios.
Okay. Thank you, John. Okay, so for those of you who don't know me yet, my name is Pascal. I guess this will be mainly the people from the Team Explorer because I'm on Voyager. And you guys are probably wondering why I'm giving this talk, a student, among all those prominent speakers here. So I was asked by ESA and NASA to just give a short overview about the work that I'm doing because it's very much related to the things that we are doing here in our workshop. And so I thought I'd just give you guys a student's perspective on ISECG and all the NEA scenarios that we are carrying out. Okay. So, as an overview, so first I'm going to talk a little bit about facts about myself. So I'm going to tell you my background, and then I'm going to introduce my workplace right now, ESA, and the Exploration Architecture Office. Then I'm going a bit into the exploration scenarios that we're currently defining within ISECG. And then I'm just going to give my own opinion, my own perspective on the work that we're doing there. Okay. So my background is in aerospace engineering at the University of Stuttgart in Germany. And I did several internships also at the European Spaceport in Kourou and at the European Astronaut Center in Germany. So my background is pretty diverse, and it's more systems engineering background. And I was also part of the space studies program of the International Space University at NASA Ames. And right now I'm carrying out my master thesis at the European Space Agency in the Netherlands at ISECG. And so the topic is basically a comparative assessment of ISECG mission scenarios for human exploration. Not only restricted to NEA scenarios, but in general, human exploration scenarios. So basically everything that comes after ISS. And so that's why my field of interest, I would say, is mainly mission architecture. And so here, just to provide two pictures. So this is me in the ESA astronaut suit outfit, and but also, of course, NASA, since we are here close to JPL. And okay. So I don't know how many of you have already heard about ESA, especially maybe the people from India or other countries. I don't know how well known ESA is over there. So basically, ESA has 19 member states. So it's the countries in dark gray over here. And I don't want to read them out. You can read them by yourselves. So we have also 8 other European Union states that have cooperation agreements with ESA. And also Canada takes part in some programs under a cooperation agreement. And we also have some Canadian trainees at ISECG. So it's very international, which makes everything more exciting, and it's all about collaboration at ESA. So the Exploration Architecture Office. The Exploration Architecture Office is a small section which is part of the ESA Directorate for Human Spaceflight and Operations, which was just recently created because before it was 2 directorates. It was the Directorate for Human Spaceflight and the Directorate for Operations, which were then merged to make everything more efficient. And so I'm part of a small team of 4 people. And basically what we are doing is we are developing the European roadmap for space exploration, which will be presented to the senior agency managers. And so we do that by analyzing different exploration architectures and strategies. And we're also part of ISECG, which I will explain in a minute. And what we do there is we define together with 14 other space agencies the global human exploration roadmap. And it's really very interesting work and very rewarding. And so we are part of several international working groups. And we also identify the European contribution to all these exploration scenarios. And we identify potential cooperation scenarios with other countries, like, for example, Japan or India or several other agencies. So what you can see here, this is what it's all about, exploring together, which is one of the slogans of ISECG. So what is ISECG? Has anybody of you ever heard of ISECG? Okay, I see 2 hands, 3 maybe, 4. Okay, so I see it's not very well known, which I expected. And so ISECG is the International Space Exploration Coordination Group. I know it's a very long name. And here you can see it's a kind of, well, organization or group of in total 14 space agencies, which you can see here. So it's all the major space agencies from Europe, United States, India, China. So all the big nations. And it was established in 2007. And so the main purpose of ISECG is it should provide a forum for exchanging information on different mission architectures and scenarios, and recommend them to the relevant senior agency members, like the agency heads, and which will then forward this information to the political decision leaders. And so what we do is we develop findings and recommendations, and just forward them to the important people. And so if you're interested in the work, you can find more information under this address, globalspaceexploration.org. So you can download brochures and an overview about the work that we're doing at ISECG. So this is basically the main product that we are working on, which is called the Global Space Exploration Roadmap. So basically it is a document, and it is supposed to facilitate the coordination and the cooperation of our space exploration activities. So this includes basically that we develop a strategy, a long-range strategy for human exploration beyond LEO. So whether it's the moon or whether it's NEA as a destination, it doesn't matter. And but also we reflect and we try to integrate the agency policies and plans as far as possible. And so this means that we facilitate near-term coordination and cooperation opportunities in 5 areas. So it's use of ISS for exploration, robotic missions, infrastructure elements, technologies, and terrestrial analogs. And as I already mentioned, ISECG is there to give recommendations. So everything that we are developing is not binding, it's non-binding. So it's a non-binding product, and the senior agency managers agreed to begin the development in June 2011. So the initial release was planned for September this year, and as you can see, we already have a draft, and there will also be a presentation at the International Astronautical Congress this year in Cape Town, South Africa. And in total, 12 space agencies have contributed to the development of this document. So, what does it look like, the global exploration roadmap? So in this chart, you see an overview about the strategy or the general architecture that we envision for the future. So as you can see here, we still try to make use of ISS as much as possible as a preparation for our future missions. So this means we continue to further advance the technologies that are already there. So basically in the areas of life support and habitation, but also communication and robotic technologies, and but also cryo, fluid management and transfer. So after we have advanced these technologies as far as possible, which we tried or we will go further into deep space. And so this basically means that here you can see all the destinations that we have in mind. And on this line, you can see all the robotic missions that will be carried out in this time frame. So as you can see here, we have a lot of missions to the moon, robotic missions, and only a few to near-Earth asteroids, unfortunately. And so we continue this robotic exploration, and then we have basically a path that divides into two ways. So we are now deciding whether we should go first back to the moon or if we should go straight to asteroids. So this is basically right now, these are the two scenarios which are called asteroid next versus moon next. And so we envision several missions to the moon on the moon next scenario, but also here for the asteroid missions as a preparation missions to the Earth-Moon Lagrange point 1. And so then if we look at all these capabilities that we need, so these are all our building block elements which enable us to perform these missions. So as you can see, there are several elements, and I think Brett Drake will talk about these elements in a later lecture. So we have several elements like, for example, the deep space habitat, cryogenic propulsion stage, etc., etc. And they will enable us to get there with always the ultimate goal, or, well, another goal, the next goal, Mars, a manned mission to Mars. So I mentioned that the path divided into two ways. So if the first path is this moon next scenario. In order to get to the moon, we found that it makes sense to first deliver a deep space habitat to an Earth-Moon Lagrange point. And, okay, this is the asteroid next scenario, I'm sorry. So in order to advance our technologies, we thought it makes sense to deliver a deep space habitat to an Earth-Moon Lagrange point to test all the capabilities like life support, etc. And then we move on to the asteroid. And then as the next stepping stone, we go to the moon, because we still think it is essential to go to the moon before we go to Mars, because we cannot test all the capabilities that we need to get to Mars on an asteroid. So, like for example, we cannot test things like rovers on an asteroid. We need to test them on a bigger planetary body like the moon. So another scenario says that we should go first to the moon, back to the moon, and then to the asteroid, and then to Mars. So these are basically the two scenarios that we have. Originally, we had 7 scenarios, and it took us quite a while to get down to 2, but it's always better to have a smaller selection of scenarios, because the political decision leaders, they are not so familiar with all the things that are involved in it, and so we thought it's better to have only 2. And okay, so In the previous lectures, it was talked a lot about the NEA Destination, so I will only go quickly through this. Why are we going to a near-Earth asteroid? Well, in general, we can say that the asteroid as a destination is somewhat of a halfway point between the Moon and Mars from a total mission energy and time perspective. So it's the perfect opportunity to test our advanced technologies in the area of propulsion, energy, advanced life support, etc. And it's the first true deep space mission that we will be carrying out, because so far we haven't been to true deep space. And of course we also have it's a high value science target, and it will enhance the understanding of impact mitigation approaches, so planetary defense. And so in all the scenarios that we discussed, a precursor mission to each crew target is assumed. So it was agreed in all scenarios that we need precursor missions. And so if we go to the next slide, this is a quick overview about the asteroid next scenario that we designed. So it's not a bad chart because I couldn't show you the bad charts, but it gives you a short overview about the steps that we want to take to reach our goals. And so as you can see here, we have ISS still under operation, and so we have still continuing missions to the ISS. But what was envisioned is to develop an additional module for ISS, the so-called Exploration Technology Demonstration Module, where we can basically integrate the exploration technologies that are needed for us to enable missions to a near-Earth asteroid or to the Moon. And we thought we already have a very expensive laboratory up there, so why don't we take advantage of what we already have instead of developing all the new things? And so this is what this is. And so as an intermediate step, we thought, okay, we should first focus on the cislunar space. So this means we would deliver a deep space habitat to the Earth-Moon Lagrange point 1 and slowly increase the duration of our stays there. So we have several missions to this deep space habitat, and as soon as we have gained enough experience on how to handle all the challenges which are connected to a deep space mission, like the radiation environment, for example, we continue with the first human mission to a to a near-Earth object. But as you can see here on the robotic exploration part, we have already here precursor missions, because they are essential for us. Because first we need to understand what are the dangers and what are the challenges that we need to overcome in order to perform a meaningful mission at this asteroid. We need to understand the physical properties of our target. So we envisioned several missions to a NEO, and then you can see after these missions we will have future scenarios to either to the Moon or always with the ultimate goal of Mars. And these are basically the elements that I mentioned, which will help us to get there. So we looked at different mission profiles with respect to the NEO mission, and so as a general summary, we compared chemical propulsion versus electric propulsion. I just give you the numbers. I don't want to go too much into the evaluation which or what kind of propulsion is more meaningful. but I will just tell you what we can get out of this propulsion techniques. So as you can see, the targets are very similar. So first, the chemical propulsion targets that we looked at had a required delta V of 5 kilometers per second, and the electrical propulsion target had a delta V of 5.4 kilometers per second. And as you can see, if we go there by chemical propulsion, we have only a surface stay of 8 days, whereas if we go there by electric propulsion, we have a higher surface duration or mission duration at the NEO of 30 days. And well, the total mass that we would need to achieve these missions is in the range of 200 to 230 tons. So we have to think about how many launches will take, or how many launches we will need to bring this mass up there. So it's either a 2-launch strategy or a 3-launch strategy. And so what mass do we basically get there? With chemical propulsion on this target, we get a mass of 45 tons. And here, at least 67 tons. I didn't have enough numbers to calculate the exact mass, but it must be at least 67 tons. And the capabilities that we have at the NEO, as you can see, we have more elements that we can take advantage of if we use electric propulsion. So we have, in addition, the space exploration vehicle, if we use electric propulsion, which will allow us to interact with the NEO, to collect samples, and to use robotic arms mainly. And so in general, the tendency is to use electric propulsion in combination with chemical propulsion. So this will be very interesting, but I guess we will also find things out on how to use the propulsion during the workshop, which strategy is the best strategy. But this will be up to our teams, so I don't want to go into that. Okay, so basically as a summary, I was asked to give my own opinion on all the scenarios. And so in my opinion, I think that groups like ISECG are necessary for the promotion of such ambitious plans as going to a near-Earth object. And but the main problem is, as you have already seen, most of you have never heard of groups like ISECG, so they are relatively unknown in public. So there must be something done to promote the work that is being done at ISECG. And so I thought it would be a good idea if students could voice their own opinion about the work that we are doing. And I was also asked by my boss to mention this because the space agencies, they want the opinion of young people like us. So we could, for example, we could create a discussion forum on all these exploration scenarios and give our input and then forward our opinions and inputs to the space agencies so that they can also consider our opinion on everything and include that in their products or documents. So a possibility could also be that we organize workshops on space exploration, for example, during the IAC or the Space Generation Congress, which is organized by the Space Generation Advisory Council. I don't know how many people are familiar with that organization. It's basically a student organization that holds this congress every year before the IAC, and it's about several workshops on certain topics. And so an idea could be to develop a workshop on this human space exploration topics, or on these space exploration topics that are being discussed at ISECG. So yeah, well, so the next opportunity to voice our opinion is the Global Space Exploration Conference in Washington, D.C., which will be next year in May. And everybody is invited to hand in a paper or just, organize ourselves. And I mean, the best time to start is now because, as you could see, the topic is quite well. It's quite hot. The topic is quite hot because the president ordered us to do this, and so, well, let's get started. And so, in the end, I would like to show you this picture, which is one of my favorite pictures on space exploration. Here you can see the space shuttle. I don't know which STS mission it was, but it's quite interesting because here in front you have replicas of the original ships that were used by Christopher Columbus. And so, well, off to new shores. And this is also a very interesting quote by Ralph Waldo Emerson: "Do not go where the path may lead, go instead where there is no path and leave a trail." And I think during this workshop, this is exactly what we are doing. And I'm looking forward to work with all you guys, and I'm pretty sure that we will get some good results. Okay, thank you.